and 2, the second object, and 3, and so on and so forth, and put the right hand curly bracket. So that is one way to do it. But what if you have to write down, let's say like 100 elements, for example, like 1, 2, 3 until 100? So that would be time consuming to do it, right? So if you want to put like 100 elements in that set, I don't want to do it. So the other way is to use so-called rule base. Rule base is to specify some root, and then the elements that satisfy those roots will be classified into this set. Okay, for example, like x, such that x is an integer number that between 100 and 1. So if I write it this way, so this will be exactly the same set I just mentioned, like 1, 2, 3, 4, 5, to 100. Okay, so that is a more concise or like more compact way to write down a set. Okay, so we have these two ways to write down a set. And finally, there's a spatial set called empty set. So usually we will use this symbol to represent the empty set, meaning that it doesn't contain anything here. Okay. So far, so good. Yeah, good. Right. So here are some quick questions you can think about it. So the question 1 is that can the people sitting behind the classroom, can you guys see the questions here? Yeah, right. Okay, so the question 1 is that which set are valid? So for example, like the first set, I write it down like this way. Is that a valid set according to our definitions? Yes? No? Yes? So if you think that is valid, please raise your hand. Yeah, cool. And the other one, I guess the rest will think this is not valid. So this is a valid set, and I think I can use this one. Oh. So the idea is that let's break it down step by step. Let's call this set A1. That contained the elements 1, right? And then the set A contained the elements 1 and the other set A1. So in this sense, this is a proper set according to our definitions. Oh, I should say like very set, right? Okay, so that is the first like sub questions of question 1. And how about the second one? Is that the valid set here? Yes? No? Yes? Okay. So like we can do it in the same way. We just need to define one more stub code. Put it. Okay. So if we define another stub, of course, let's call it B1 contain A1. That is right. Then the set B, actually we can write it as contain the element 1, then the set A1 and the set B1. Okay, so like put it this way, that would be more clear, right? And the C is also a valid set. Yeah, cool.
How do I identify that object is mathematical? Like two eyes.
Are mathematic?
Because according to the definition, you say that the object should be a mathematical object.
Okay, mathematical object. So here are some examples here. So for example, like numbers here in this index example, they are all numbers. So that is one of the mathematical object. And point, for example, like if you are talking about points on XY plane, then that could be a mathematical object here, or functions, or other set. For example, like the last examples here. These are empty set, and these are all other sets. Okay.
So like two eyes, I should assume that it means two.
Sorry?
The last object is A. I should assume it means the second.
I think that is not the. Maybe we can talk about it later about like to figure out what part you don't understand it, but I don't think that really be a barrier for you to understand this concept. Yep. Okay, so let me move on. And then move to the second questions. Can the set be an element of itself? For example, like put it A equals to like a set of A. The answer is no. According to our definition here, why that would be come on. Right. According to the bullet point here, it can only be other sets. Okay, so put it this way is wrong. But if you are very interested to these questions, you can Google Russell's paradox, right? So it's a very famous paradox here. I mean, I found like one of versions of it is the statement is that they let A be the set of all sets that are not members of themselves. So if you put it in a more mathematical way, it will look like this one. Okay, so if you put it this one and says that now if A is in A, then it implied that A is not in A. Oh, let me explain the symbols here. So this is the elements is in this set, okay, and this is equivalent. So this statement implies this one, and also this statement implies this one. And when you put the slash here, it means that this element is not in the set here. Okay, so that is a little bit explanations here. So this is Russell's paradox, and paradox. Right, and if you are interested in very difficult questions, you can look it up, but it's not necessary. So just as a side note here. Right. Any questions before we move on? Yeah. The third one is also valid. Yeah, but you can just like analyze it in the same way. Okay. Okay. right? And we can say that two sets are equals by using this equal signs here. Right. And if and only if like they have all like both set has both set have the same elements here, right? And as I mentioned, we use this symbol to say that some elements in the set, and we use this symbol to say that this element is not in. Okay, and so you know that this means equals and this means not equal. Okay, so that's the thing that I want to say here. And also we have another symbols here, which is called subset.